Hello everyone, we got a problem here in basic mechanics to solve, and this problem appeared in the GRE physics exam. In this problem we are given a system of two blocks, block A and B, and having masses equal to 16 and 4 kilograms respectively, and there is a minimal force acting on this system of blocks such that block B does not fall under the influence of gravity. The horizontal surface is given to be frictionless here, and the coefficient of friction between the two blocks here for this surface between the two blocks, block A and B, is given to be 0.5. So the magnitude of F is most nearly equal to one of these five values: A, B, C, D, and E. We need to find out the closest value here. Now the minimal force F acting on the system of two blocks, block A and B, such as to keep block B from falling, should satisfy Newton's second law of motion, which I write here as F is equal to mass of block A plus mass of block B. I consider it as one system times the acceleration A of the system, which of course is in the same direction as the force, the applied force. This can further be written as mass of block A times the minimal acceleration A plus mass of block B times the minimal acceleration A. Now this part of the applied force F, that is mb times A, is the minimal force on block B. Call this as mb times A, and this force can be considered as the normal force on block B from the surface between block A and block B, and this provides the necessary frictional force upward on block B. Call this as Fs, which keeps this block B from falling. That is, the magnitude of this frictional force should be equal to the magnitude of the weight of the block. Call this as weight of block B, mb times g. So let us write the equations now. The force of static friction, which is the minimal force required to keep block B from falling, F is equal to mu times the normal force on block B. Mu here is the coefficient of static friction for the surface between block A and block B times the normal force on block B, which is mb times A here, and this should be equal to the weight of block B, which is mb times g. Now you see this mass cancel out here, and I get from here the value of A equal to g divided by mu. And if I take a value of 9.8 meters per second square for the value of g divided by mu, which is 0.5, here it is given 0.5, I get a value of 19.6 meters per second squared for the value of A. And now if I put this value of A in the first equation for the minimal force F, I get its value equal to, F is equal to mass of block A, which is 16 kilograms, plus mass of block B, which is 4 kilograms, times the acceleration A, which is 19.6 meters per second squared. And this value is equal to 392 newtons. And this is the closest value possible to 400 newtons here. Option D. Thanks for watching, guys.